design and configure a complete university network from scratch using this proposal. This is it. Albion University is a large university situated 20 miles apart. The university students and staff are distributed across faculties and departments. And these are the faculties. We've got Health and Sciences, Administration and Library, Engineering and Computing, Art and Design, School of Law, Small Campus, and Data Center. Each member of staff has a PC and students have access to PCs in the lab. These are the requirements. You are supposed to create a network topology with the main components. These are the main components. We've got main campuses. 2 campuses are joined. Main campus has got Building A, hosting School of Law, Administration and Library, Faculty of Business and Economics and Health and Social Sciences. Building B, Faculty of Engineering, Computing and Faculty of Engineering and Computing, and Faculty of Art and Design. Building C, the IT department hosts the University Data Center and small campus with the Faculty of Postgraduate Programs. This is Masters and PhD. Requirement B, you are expected to configure devices to provide end-to-end connectivity. Each department or faculty is expected to be on its own IP network. The switches should be configured with appropriate VLANs and security settings. The OSPF will be used to provide routing for 2 routers in internal network. Design a university network given this address space. Subnet and distribute accordingly. The 2 routers are under this network. The devices in Building A and B will be expected to acquire the dynamic IP address from a router based to the DHCP server, while computers in the data center or in small campus should get IP address from the DHCP server. So this is the proposal that I'm going to use. To minimize on time, I had already created this topology in Cisco Packet Tracer. As you can see, this is the main campus, Building A, Building B, situated on this router for main campus. Then 20 miles away to small campus here, and this small campus is just with the data center. Data center is situated in the IT department. This is it. So the link between these 2 routers, this is the network that we've been authorized to use through this proposal. As you can see here, that the 2 routers are under this network. Then all the faculties and departments have to get the IP address or their respective address space or networks from this particular large address space that we've been given. As you can check on this topology, this is just for simulation, because in real environment it is beyond this. So this is the School of Law under VLAN 10, tapping ports from 1 to 3, given this network. Then this is Administration and Library, VLAN 20, ports from 4 to 5, 4 to 6, that is, given this network. And as you can see, all this network is coming from the network that we were given to subnet here. I'll show you how I arrived at that. So this is it, Faculty of Business and Economics, Health and Social Sciences. On this switch, I had already created some VLANs for the School of Law, Administration, Faculty and Business, Health and Social Sciences. We can check. even given this switch the host name, enable show VLANs. You can see here I have created some. We've got low here. It is ranging from port 1 up to port 3. Administration VLAN 20, port 4 up to port 6. VLAN 30 business economics not yet assigned switch ports. VLAN 40 not yet assigned switch ports. So let me assign switch ports to these VLANs as I proceed. I'll go to global configuration mode. Then I start with the VLAN 30. As you can see, that is not assigned here. 30 and 40, they are just created but not assigned switch ports. So 30 and 20, this is 23, 22. Okay, so interface range fast Ethernet 0 20 20 20 to 20 23. Let me put 24. Switch port mode access, switch port access VLAN 30. Exit interface range fast Ethernet 0/10 to 16. Switch port mode access, switch port access VLAN 40. The moment I do that, then exit back to global configuration mode, exit again back to switch privilege mode, then show VLANs. You can see now 40 is assigned ports starting from 10 to 13 to 16, I mean, sorry. And then 30, VLAN 30 is assigned ports from 20 to 23. So it's okay. So I have finished this section. This is the trunk port. This gigabit 0/1, it is the port facing the router. So this one will serve as a tunnel to forward the traffic coming from this particular faculties, whereby School of Law can communicate with the Faculty of Business. That will be the engine to forward that particular request to the router to determine. So let me configure trunk port. Interface gigabit 0/1, switch port mode trunk, description trunk port for main campus, then no shutdown, though all ports on a switch are all up upon connection. Then I save. To save configuration, just right copy running config startup config. This one saves your current configuration that are always stored in RAM into the NVRAM. So upon your device restarting, your configuration cannot be lost. So I'm done. On this section. Let me go to building B. This building B, VLAN 50, Faculty of Engineering and Computing. Under this network, port 1 to 6, that is Faculty of Engineering. Port 10 to 15, that is a Faculty of Art and Design. So let me then on this switch, On this switch, I'm going to create, that is the switch. I'm going to create VLAN 50. Before I reach there, hostname, Albion, building, B, underscore switch 2, banner, message of the day, no intruders, allowed. Then from there, VLAN 50, name, engineering, VLAN 60, name, at underscore design. In Cisco Packet Tracer, the name, when you giving the names, you should not give the spaces. You better use an underscore. The iOS won't accept such kind of naming. After that, let me now exit this mode, then assign switch ports interface range, fast Ethernet 0/1 up to 9, switch port mode access, switch port access VLAN 50, then exit interface range fast Ethernet 0/10 up to 18, switch port mode access. You must specify the mode first, then switch port access VLAN 60. You can use end to return you automatically to privilege mode, or you can use exit twice, then be back on this mode. So let me save configuration, copy, running startup config. To disable this lookup that is disturbing every time a wrong command is configured, you just say no IP domain lookup. Then even if you type a wrong command, it cannot be interpreted. So that is it. You can also say write memory. It's one way of also saving. So I'm done with this switch. Let me verify configuration. To verify configuration that indeed VLANs have been created, you use show VLAN. You can see VLAN 60 at and design is created, switch ports assigned. Switch ports assigned. Then VLAN 50 also switch ports are assigned. Next step, on this switch, I'm going to create two VLANs here. So one will support the small campus postgraduate, then the data center. The data center will pick from port 1 to 8, then the remaining ports goes to the postgraduate. So VLAN 70 and 80. Enable config terminal, host name, then data center, switch 3, then banner, MOTD, message of the day, at no intrusion, then VLAN 70, name, postgraduate, small campus, then VLAN 80, name, data center, exit from that mode, then assign switch ports interface range fast Ethernet 0, 1 to 10, switch port mode access, switch port access VLAN 80, then exit. You repeat the same interface range fast Ethernet 0, 11 to 20, switch port access. You can say switch port access, then VLAN 70. It is just the same as writing switch port mode access, then switch port access, then VLAN number. So that is it. You can describe VLAN. This is good when it comes to troubleshooting. Then write memory. So I have finished configuring these switches. So created VLANs on this switch. So building C, building B, and building A and B building in main campus are covered. So the remaining section on this topology, trunk port, here it is created. Let me now move in configuring trunk ports. Interface gig 0/1 for main campus building A, switch port mode trunk, then switch port trunk allowed, then we specify the VLAN 10, 20, 30, 40, 10, 20, 30, 40. So all these VLANs I have specified here, they will use this particular port to communicate using this router as their decision engine, this router. So that is it. Let me save. To save, if you want to save and you are not in privilege mode in Cisco iOS, you just use do space, then write memory. It will work just as while at privilege mode by writing WR or copy, run startup, still it will work. So that is it. I have finished configuring trunk on this port, but this port is not up because it depends here. This should be up. That's when this port also should be up. By automatic, all switch ports are up by default from the factory. But you will only see the connection if a device has been connected on that table, on that particular port. So gig 0/2 for this, VLAN 80, VLAN what? VLAN 60 and 50. Config interface gig 0/2, switch port mode trunk, switch port trunk allowed, VLAN 50, 60. Do right. Trunk port for building B. So I have finished configuring trunk port, this trunk port here. So let me also configure this trunk port here. Gig 0/2 on the data center switch. It will encompass VLAN 70 and VLAN 80. Interface gigabit 0/2, switch port mode trunk, switch port trunk allowed, VLAN 70, then 80. Description, data center, trunk port, and then write memory. So I have created trunk ports on 3 switches and allowed those VLANs to communicate. Next thing, this autonomous system, these 2 routers, for traffic to flow from School of Law or law school to Faculty of Business and Economics, or Health and Sciences, or Faculty of Art and Design, or to communication to data center, all these routers should be in position to communicate. Meaning, 1, the router should have the correct IP address from the correct subnet. Inter-VLAN routing should be configured, that is 802.1q. That concept must be configured in these interfaces facing these particular buildings. So let me, and remember, according to our proposal here, that the 2 routers we shall use OSPF. I'm going to show you how to configure OSPF if you've been struggling with this concept of dynamic routing using this protocol. And also remember, we've been tasked here or directed in this requirement here that the device in building A and B are expected to get automatic IP address assignment from router-based DHCP server. It means we are going to configure Cisco router to serve as a DHCP server. But while computers in small campus should get IP address from DHCP server, it means now in small campus we are going to configure the real server now just to be dedicated as DHCP. We are not going to use the router to serve as DHCP server in this section. When we reach in this building C, we are going to use this DHCP server here to distribute IP address here, but not here, because servers host shared services and always should be configured with static IP addresses. So this router, I'm not going to configure it as the DHCP server. I'm only going to configure this one so that it can provide IP address for these particular faculties and these particular faculties. That's building B and building A. So let me start. In this section, there is no IP address that I'm going to assign on this interface because I'm going to use what we call inter-VLAN routing, creating sub-virtual interface or SVI to help those faculties communicate. No, enable, then we set the clock set. Right now it is 14:16 01 14 March, date, then the year, date, month, then the year. Then configure terminal to move to global configuration mode. After there, host name, main campus, router 1, then banner, message of the day, no intruders. Banner is just a kind of a message that is displayed when logged into that device. It just warns you. Never ever configure a banner that welcomes you into the device. That's wrong administration technique. After there, I'll go to the interface facing this building A. This is it, gig 0/0. Interface gig 0/0, then no shutdown. The moment I put no shutdown, immediately this interface here, it turns into an amber, and then eventually it becomes green, meaning there is steady connection. Now you can see it is in amber. Then when I fast forward, then it will become just green. You see, now it is green, meaning it's up. You see, the status has changed to up. Description, main interface for building A. After there, exit. Then I'm now starting creating the sub-virtual interface on that main interface. So gigabit 0/0. But before I go to that, let me show you how I arrived at subnetting of all these particular faculties in three buildings: building A, building B, and building C. This is it. This is how I did my subnetting. You see, every department is having 14 usable IP address. This is the IP address space that I was given. That was on the proposal here. You can check. This is it. So I used this to come up with, I did subnetting and come up with the multiple networks here depending on my need. So I had 9 networks. So this is where I'm going to use my networks up to this space to get the number of networks. Remember, in networking, there are this concept that your network should be scalable, should be fault tolerant, should be available, reliable. All those concepts, to achieve them, there is certain steps you have to adhere to them. For example, ensure that your subnet, your address space has enough IP address to cater for the available users or nodes in that network, and also have some for the future. So in my steps, I just needed 9 networks, but you see I have almost 17 networks. I have 16 networks, I mean. So 16 networks, meaning when this university maybe in the future decides to expand with the other branches, still I can just use this particular remaining subnets here. So to create a subnet, you take 2 raised to power n. This is the equal to the number of subnets. These are formulas used in subnetting, IP addressing, as subnetting is concerned. So n equal to number of host bits borrowed from host ID to network ID. So these are the concepts that you should be familiar with. Then, to get the number of IP addresses that can be assigned, you take 2 raised to power n, which is the number of bits borrowed from the host to the network, then minus 2. Minus 2, this 2 means 1, this network ID is never assigned as an IP address on the node or on the computer. Second, the broadcast IP is not assigned. So when you remove the broadcast IP and the network ID, then that is the essence of these 2 here. So this one gives the usable or valid IP addresses. So that is it. So this is it. These are the formulas you should master. So these are the things that helped me to arrive at this. So this one, I assigned it a School of Law, then School of You can now check here, School of Law here, law school, gave it 10, but remember /28 because then this is 16, then this is 32 that way. But when it reached between the two routers, we were given this network to use between the routers, because this router here and this just need two valid IP addresses. So in this section, 2 raised to power 2, that's 4 minus 2, I have two valid IP addresses that I can assign on this interface and on this interface. Then between them, I'll use the OSPF. Okay, so that is it about subnetting. Let me go back here in creating my sub-virtual interface, starting with the VLAN 10. To create a sub-virtual interface, you go to the main interface, period, then the VLAN ID of that particular department. After there, you see it's up, we describe law school, then encapsulation. We first start with encapsulation before IP address, before we assign IP address. The reason being, we've got two types of protocols that are used here, so that you should be specific what protocol that you are going to use in inter-VLAN routing. In my case, I'm going to use 802.1q. So encapsulation dot 10. So that is it. Then IP address. IP address here on the sub-virtual interface, I will be assigning the first IP address from that particular subnet. And you can see from the first subnet, the first IP is 192.168.10.1. Then the subnet mask is 240. So that is it. Just come here. IP address 192.168.10.1, 255.255.255.240. So I'm done. I'm done creating a sub-virtual interface for School of Law. Then exit. Then next I move to administration and library 0/0.20 encapsulation dot 20.1q, then VLAN ID, then IP address 192.168.10. You see it ends with the 16. So I'm not going to use 16 because we've agreed that network ID is not ever assigned as an IP address. So I'll start with 17. That's the first IP address in that segment. Description. There is no need of even no shutdown, because the moment a sub-virtual interface is created, its status changes to up. So next, I'm going to configure Faculty of Business 30. So the first IP is 33. Switch to virtual interface. Then the second I move to social sciences, health and sciences .40. .40 encapsulation .40. IP address, and then 48, the first IP address is 49. No shutdown. So I have finished creating some virtual interface here. We can verify what I have done here using show running config. Then we can scroll down here. This is the main interface. You can see that there is no IP address assigned here. The interface, after the main interface, now I have used the main interface to subdivide it into multiple virtual interfaces that shall be used by these particular faculties for communication. So you see 0/0.10, that is for law school, .20 library, .30 business, then .40 is the health sciences. So that is it. The next step, I'm going to create DHCP pools for these particular faculties in building A. So I will start with the law school. IP DHCP pool law, then default 192.168.10.1 network 10.0 DNS. I'm going to give it IP address from this segment, so 115, that is the DNS here. So .10.115 domain name Netlabs hub.com, then exit. I exclude even there is no need of excluding, so this is just a simulation. IP DHCP pool for admin library default, that is the gateway 17. DNS 115. So I have created two pools for law and library. The next, faculty of business, IP DHCP pool business underscore economics default 192.168.10. That's 3 network domain DNS. We've resolved to use 192.10.115 192.168.10.115. So the last one on that router, the DHCP pool default 49 domain, domain Netlabs, I can exclude IPDHCP pool, exclude 192.168.10.1 for law school. I want them to start because they are 14, so let it start with the 5. Then IPDHCP pool, IPDHCP exclude .10.17 20 IPDHCP exclude 33, that is the faculty of business, .168.10. Let it start with 35. IPDHCP exclude, I'm reserving 49, 65. Write memory, show IPDHCP pools. So you can see this is pool 1. The pools have been created. You can see them here. So this section I'm almost done. So it has remained this one. The same steps I did here, bringing up this interface, creating some virtual interface, then creating the HCP pools. This is gigabit Ethernet 0/1 config. It is a 64 and then 80. IPDHCP exclude, let me exclude. The first IP address is 65, then let it start with the 70. '81, 85. So you can see this is for faculty of data design, then engineering and computing. So from here, let me create the HCP pools, IPDHCP pool, engineering, default, network, DNS, domain, end. So that is the step. Then I repeat the same to create the pool for art and design faculty. So IPDHCP pool, then the name of the pool, maybe design, and then default is the gateway that the computers in that department will use to locate the server. That's 81. Then network, then domain, then DNS, save configuration, write memory or copy, running, startup, config. To disable that, no IP domain lookup. So I'm done configuring the HCP pools for this faculty and this faculty. Then let me bring up the create switched virtual interface, that is inter-VLAN routing on this interface gigabit Ethernet 0/1. Config interface gigabit 0/1. No shutdown. Description main interface for building with exit interface gig 0/1. Then you can see this is VLAN 50, then 60. 50 is on subnet.64. Then faculty of art and design is on the network 192.168.10.80. So on this network, I'm going to create sub virtual interface for this VLAN. .50 encapsulation dot .64. Then exit, exit to global configuration mode, exit to global configuration mode, exit to global configuration mode to configure the sub virtual interface for this VLAN. That is 80. Okay, so interface gigabit 0/1.80, not 80, it is 60. Encapsulation dot 60 IP address 192.168.10.81. 81 because it is coming from this subnet. Then 255.240. end. So from here, remaining with this, let me assign these interfaces using a shortcut. Gig 0/0. You just click here, come on the interface, put here an IP address. I give it 1. Then because it is /30, that is 255.255.252. Then turn on the interface. Then this is gig 0/1. Turn on the interface 10.10.10.2. So already assigned the interface. Then let me finish with this section. I've already created the VLAN, so the VLAN routing on this interface, config host name, data center, interface, gig 0/0, no shutdown. Then .70 then encapsulation .70 IP address 192.168.10.97.255.255.255. 240. So I'm done. .240. Interface gigabit 0/. So from here, Let me assign static IP on this DNS server. On this DNS server, so that it can get IP address, or it can be accessed by the computers in different faculties. Static IP 192.168.10.115. This is 240. The gateway is 213. It's 113. DNS is the same IP address. Come configure DNS server, Netlabs hub.com, then the IP address, then add, turn on the server, save. So that's how we configure the DNS server. Let me bring up the interface, VLANs. Interface VLAN 50 int VLAN 70. Let me check if it can receive IP address automatic. So you click on desktop, then DHCP, then you enable. Now let me check if at all it can receive IP address automatic. You see it has received 86, so it is successful. Let me check this one. It has received the IP address, you can see. So that is it. 255. $34. So my computers are able to get IP address. Let me start with this. It can get IP address. It can get IP address. So let me configure OSPF on this side. To configure OSPF, to configure OSPF, to configure OSPF, we can use OSPF or RIP version 2 still to ensure this network works. RIP. 192.10.112.96, no auto summary, and end. So this is it, using RIP to synchronize this network. Let me check if this one receives IP address. This one, it has received the IP address. Let me check. So let me check if at all there is communication with the DNS ping. Destination unreachable. Now let's troubleshoot this network. Let me bring up the VLAN interface, int VLAN 70 IP address. IP address, then end. So for this one, we were told that it should get IP address from this DHCP server. Let me configure it with the static IP address. So I have configured the DHCP server. Let me check if it can receive IP address. It has received IP address, so it's okay. Let me enable the IP address here on this computer. On this computer. So let me test connectivity between this computer and the DNS server. There is communication, you can see. There is communication. There is communication. There is communication. Let me reload. So on this, why this is not getting IP, it has gotten the IP address. You can see the access point, let me pick the wireless device here. You see there is connection. There is connection, so my network is working. Successful. Ping. Let me check. So I have created 10, 20, 30, 40, 50, 60. So gig 0/1 50 60. You see, the problem is that on sub-virtual interface for VLAN 50, I did not assign IP address, and that is the issue. That is this one. I did not assign IP address on this one. 50 this network, so it's not getting IP address. 50 60 what? 64. So this is it. Interface gigabit 0/1.50 encapsulation.50 IP address 192.168.10.65 255 255 255 240, then end, then right. Then let me check. You see, it has received the IP address, so my network is okay. It has received 72. What about this one? This one here has the network. This one is also. Let me ping the DNS is not reachable. Why? So it's okay. Let me try communication between this computer, this computer 1056. What about this one? 10.6. So ping there is communication. So as you can see, this computer in the School of Health and Social Sciences can communicate comfortably with computer in the School of Law. This computer 10.6 is this computer one. Let me show you this one. You can see the IP address. What about this? Let me enable it. Let me enable it. That has got an IP address. In the School of Faculty of Business, let me check if at all it can communicate with the School of Law. Ping. So there is communication here and here. So communication happens here. Let me check on this router. Show running config. So it's okay. Let me check if at all communication happens in this point. This is .71. Then this is that is .88. So let me ping 71. Ping 192.168. 168.10.71. Let me give it time. Communication happens in the school, in the Faculty of Art and Design. So 71 is this computer. Then 88 is this one. So communication happens here, Then let me check this side. This is how an enterprise network is troubleshooted. Configuring is not a big deal. The deal is where bringing the network up. Mistakes do happen. So this one has failed to get IP address. Why? So we check on the router. You start by checking the VLANs. All the VLANs are okay. The VLANs are okay. Sub interface VLAN are configured well. Okay. Then check the DHCP. gateway. That's the gateway DNS. Then start with this one. It's okay. What about the IP address configured? 116. It's okay. What about this router? This router is also okay. This router is also okay. And finally, it has got an IP address. Finally, just check. So configuration can happen. Thank you so much for following. Thank you so much for following. Next time, if you want this particular file, you can ping. You can DM your email, I'll share with you. Or if you want these files, I can share with you. Feel free to subscribe to Netlabs Hub. Thank you.